And we're now doing 6 through, well, starting with 6. Here we go. Let's see, S equals cotangent of 2 over t. Again, taking the derivative of S with respect to t. So ds dt. Derivative of cotangent is negative cosecant squared. Keep our initial input and take the derivative. 2 over t is the same as 2t to the negative 1, the derivative of which will be negative 2 t to the negative 2. And so we rewrite this, negative and negative makes 2 cosecant squared 2 over t times t to the negative 2. We'll put this down here. T to the negative 2 is over 2. We can keep it like this, or we can change this to 2, because we know cosecant is 1 over sine, and make this 2 over t squared sine squared of 2 over t. Either one would do just fine. Number 7. Y equals square root of x plus 1 plus 1 over the square root of x. Take each of these singly, remembering that the square root of x is the same as x to the 1/2, and that 1 over the square root of x was x to the negative 1/2. So in taking the derivative of each, the derivative of y with respect to x, let's see, it says 1/2 x to the negative 1/2, 0, negative 1/2 x, negative 3/2. Derivative's done, but let's clean this up a little bit. Let's make this 1 over 2 radical x minus 1 over 2. So the 3's up top, so that's cubed. 2's down the bottom, so that's square root. So that's the square root of x cubed. Now we have the square root of x cubed. That's the same as the square root of x times the square root of x squared, which is the same as, this just goes to x radical x. So 1 over 2 radical x minus 1 over 2x radical x. And we're awfully close. Common denominator would just have an x over here. So let's put an x there and an x there. So this would equal x minus 1 over 2x radical x. So the derivative was done. Algebraically, this is just a little bit cleaner. Number 8. Y equals x, the square root of 2x minus 1 plus 1. Got a product, two things multiplied, remembering that 2x plus, the square root of 2x plus 1 is really 2x plus 1 to the 1/2. The derivative of which would be 1/2 2x plus 1 to the negative 1/2, chain rule, times 2. and the 2 and the 1/2 would cancel out. So that would give us 2x plus 1 and negative 1/2. And the derivative of x is just 1. So apply the product rule. Product rule. Well, I did that in the last video. See the last video for product rule. Derivative of y with respect to x. You would do the first times the derivative of the second. Plus the second times the derivative of the first. And clean it up at all? A little bit. Derivative is done, but let's make this x over the square root of 2x plus 1 plus the square root of 2x plus 1. And we can combine these two. This is a fraction, this is a whole number. I've put this over 1 and then get a common denominator. I'm going to multiply by radical 2x plus 1. You have to do that on top too. Square roots will cancel. Bottoms are the same. So we just have x plus 2x plus 1. That was 2x plus 1. All over the square root 2x plus 1. And then cleaning it up a bit, 2x and the x goes to 3x plus 1 over the square root of 2x plus 1. There's a radical in the denominator. Really don't care. You can multiply top and bottom by radical 2x plus 1, but make it look worse and not better. Number 9. R equals secant of 1 plus 3 theta. I'm going to take the derivative of r with respect to theta as dr d theta. Derivative of secant is secant tangent. And let's put up that rule. Derivative with respect to theta of the secant of u equal to the secant of u times the tangent of u times the derivative of u with respect to theta. So this, even though we have two of these, it's not like the chain rule. You don't have to put a du d theta for each one of these as a formula. That's how it works out. We can prove it in a later video if we so choose. That will be secant of 1 plus 3 theta times the tangent of 1 plus 3 theta times the derivative of 1 plus 3 theta, which is just 3. So rewrite to make it look nice. 3 times the secant of 1 plus 3 theta times the tangent of 1 plus 3 theta. Number 10. R equals tangent squared of 3 minus theta squared. We'll do the same thing, but we're going to have to use the power chain rule. Take the derivative of r with respect to theta. Tangent is squared. So let's rewrite that tangent squared as something in parentheses squared. Bring down the 2. Leave what's in the middle. Goes to 1. Now we need the derivative of tangent. Derivative of tangent, the rule, secant squared, derivative of tangent of u equals secant squared u du d theta. So we'll apply this. We need the derivative by chain rule. Secant squared of 3 minus theta squared. And now we need the derivative of what's inside here, again by chain rule. Derivative of negative theta squared is going to be negative 2 theta to the first. Then we can just clean a bit. Negative 2 times 2, negative 4 theta, tangent of 3 minus theta squared times the secant squared, 3 minus theta squared. I don't see any reason not to leave it like that. We do have a tangent and a secant sitting here. We know that secant squared is equal to 1 plus tangent squared. I don't see how that would make things any cleaner. But it would all be in tangent if we wished.